This video is about finding the inverse of a function. So I'm going to write a function f of x that equals to x to the fifth minus 7, let's say. And the function that I've written is a one-to-one function, so an inverse function does exist for this one. So the steps for finding the inverse of a function, it's 4 quick steps. The first one is to replace f of x with the variable y. Then this, so if we did that, the first we would replace this right here. And then the second step is to interchange x and y. So right here, and we're going to say x is equal to y to the fifth minus 7. They just switch places. The third step is to solve for y. So if we're going to solve for y, we want to isolate the expression that has the y in it. So first we're going to add 7 to both sides, and we get y plus 7 is equal to y to the fifth. And we want y to the first power, not y to the fifth power. So now we'll take the fifth root of both sides of this equation. The fifth root of x plus 7 is equal to the fifth root of y to the fifth. The fifth root of something to the fifth is just that something, so on this side we just are left with y equals to the fifth root of x plus 7. The last step is to replace y with f inverse of x. So f inverse of x is equal to the fifth root of x plus 7. Okay, now if they ask you to verify that f of x and f inverse of x are inverses of each other, you can do that using compositions. So I'm going to show you how to do that. Here's the composition you must take. F of f inverse of x. A function and its inverse, when you take the composition, they undo each other. So the initial input is an x, so when you apply a function to its inverse or vice versa, you get the initial input back out. So we must show that this is true, and we also must show that f inverse of f of x is also equal to x. So let's do f of f inverse of x. The first step with this is to start with the innermost parentheses, which is this f inverse of x. We want to replace f inverse of x with what it's defined to be. It is defined to be the fifth root of x plus 7. So this is equal to f of the fifth root of x plus 7. So now the next thing is to replace every x that we see in the f function with the fifth root of x plus 7. So the f function is equal to this, x to the fifth plus 7. So I'm going to write, instead of x, I'm going to say this is something to the fifth minus 7. And what I'm replacing x with is always found within these parentheses. So it's going to be the fifth root of x plus 7. Then we evaluate this. The fifth root of x plus 7 to the fifth, or the fifth root of something to the fifth, is just that something. So in this case, x plus 7 is what is left. So we have x plus 7 minus 7. 7 minus 7 is 0, and we get back x. And so that part worked out very nicely. Now we're going to take f inverse of f of x. We'll take this composition. So the first step is to replace f of x with what it's defined to be. We want to say f inverse of x to the fifth minus 7. So now we want to replace every x that we see in the f inverse function with x to the fifth minus 7. So that looks like this. F inverse of x is this function right here. So we're going to take the fifth root of x to the fifth minus 7. And then underneath the square root, it's plus 7. So we evaluate everything underneath the square root. What is in front of this parentheses is a 1. You don't actually need the parentheses, or you can think of distributing the 1 across that parentheses, and 1 times x to the fifth is x to the fifth. 1 times negative 7 is negative 7. So really you're looking at this, x to the 5th minus 7 plus 7. Negative 7 plus 7 is 0, so we're left with the 5th root of x to the 5th. The 5th root of something to the 5th is just that something, so in this case we also get x.